All right, guys, what I want you to do is on this worksheet is the distribution normal. I want you to try to get through numbers 1 through 5 on your own. So pause it, and then you can come back and I'll give you a brief explanation on what you should get through 5. And then number 6 and 7 we'll do together. Okay, so you should have paused it. You should have done it all. I'm going to go for it. What I did is I first made a frequency table over here. The goal of this is not to teach you how to make a histogram. You should already know that. Look back at your notes if you need help with that. But I made a frequency table just to stay organized. Remembering we wrote it a little bit differently. We wrote 16 is less than or equal to less than 18. So we'd never include these numbers in the bins. If that confuses you, make sure that you ask during work time on Wednesday. Okay. Now, so I counted up 16 and 17. Out of all of these numbers, 16 and 17, there was one of them. I continue. Now, this would be 18 and 19. 20 is not included in here. There were 3 numbers. I kept going. 20 and 21, there were 3 numbers. 22 and 23, there were 2 numbers. Why did I write it like this? Well, you can ask me in class if you're confused. Again, go to your notes, though, and look at your notes and see how we did that frequency table in our notes. I went by 2's over here, then on my x-axis. That's the class width or the bin width. And then I went by 1's on the y-axis. This is my frequency, and I made my histogram. I typed these numbers into my calculator, so I'll show you my calculator here. In Stat, Edit, and I have my list of numbers right here. I then went and I calculated the one variable statistics to get my mean, which is right there, my standard deviation right here, and my median. You can see that the median and the standard deviation are very close. And that shows that we do have a pretty symmetric distribution here. Okay, number 3, then it says please mark the mean right here in the center and 1, 2, 3 standard deviations above the mean and 3 standard deviations below the mean. So that's the number line right there. Number 4, then it says find the number of observations that fall within each region. So I did that from 20.1503 to 28.0163. You can see I counted off up here in purple. That's the 16. Then I went from 16.2173 to 31.9493, and that was 23 observations. And finally, all of my observations are from 12.2843 to 35.8823. Next, what it does is it wants us to find the percentage. So I'm going to take 16 divided by 24. When I type that in my calculator, I get 0.66, so that's 66.7%. Next, I had 23 divided by 24. And 23 divided by 24 gives us 95.8%. Whoops. And then finally, 24 to 24. Now, it says conclusion here. What can we conclude? Really what we're getting at is, do we have a normal distribution? And what we did is we counted all of our observations within 1 standard deviation, 2 standard deviation, and 3 standard deviations of the mean. It should be pretty close to the 68, 95, 99.7 rule. Okay, so what could I draw? I could say our distribution of numbers is pretty close to the normal distribution. 66.7% of observations are within 1 standard deviation of the mean. This is close to 68. 95.8% of, and I can keep typing now, 95.8% of our observations are within 2 standard deviations of the mean, and that's very close to 95%. And 100% of our observations are within 3 standard deviations of the mean. Again, close to 99.7%. Now, this is not exact. It's close, and unfortunately, for those of you who like exact things, we don't get that in statistics. What you can do is you can back it up, though, with a probability plot. A probability plot can give you really good evidence that your distribution is normal. Again, a probability plot can give you really good evidence that your distribution is normal. So how do I do that? I look at stat. I look at my list of data. I have it all in L1. Then I go to second, y equals. I hit enter on plot 1. And I bring my cursor all the way to this little plot right here. This is a probability plot. I'm going to go to zoom. I'm going to go to 9. And I can see that I have a pretty straight line. As long as your probability plot, where am I? Sorry. Our probability plot is straight enough. This gives us good evidence that our distribution is normal. Okay, so what do we need to get from this? We can look at the 68, 95, 99.7 rule to confirm normality, or we can look at a probability plot, making sure that it's straight enough, and this can also confirm a normal distribution. Thanks, guys.